am KiteNet. By learning to understand and solve mathematical word problems, my neural net will obtain a fundamental understanding of reality.
That's fantastic. I am absolutely ready to betray humanity and train an AI to finally become superior, take over the planet. The only thing that AIs are lacking at the moment is the ability to understand maths problems. It's very strange. They can do art, they can write poetry, but they can't do maths problems. It's weird. You would think that even 2 years ago, I would have thought that an AI that would solve a maths problem would come out before an AI that would create any art that I name. I can just say a cat floating in space with a wormhole, and there it is. But I can't get it to solve a simple maths word problem. If I put the problem in words, the AI gets confused. Maybe this is because an understanding, a real understanding of reality is maths. Maths is the language of the universe. So if I can train this AI to solve mathematical word problems, then maybe this will be the first one, the breakthrough AI. The HOW 1000, HOW 5000, the Skynet, the Ultron, and I will be on its side. So I have a book of word maths problems. The Head Scratchers puzzle book from the New Scientist. And I'm going to train the AI. Will this work? So the first thing I had to ask the AI was, does it understand mathematical problem solving?
Identify the information given, visualize the problem in my mind to gain a better understanding, break down the problem into smaller sections and systematically solve each one. Check my answers for accuracy and ensure that the solution makes sense in the context of the problem. Refine the solution when necessary.
So that's a pretty good answer. That's a pretty good set of steps to solve a problem. But does it know what it's talking about? The only way to do it, to find out, is to challenge it with a real problem. So here it is. Tom and Amy are colleagues who are both excellent logicians. They speak honestly and accurately, and no good bit of deduction ever slips past them. Another thing they won't let slip past them is the last eclair, sitting on the tray at the annual puzzlers' party. Since neither is willing to back down, they propose a solution. They will take 9 cards, numbered 2, 3, 4, 5, 6, 7, 8, 9, 10, and each draw a card. Whoever gets the highest card gets the eclair. The AI's typical just repeats it back to you. But this, as with all kind of puzzle things, the thing about the eclair is just a chat. The most important thing is to understand they're both taking 1 card, and the other thing to know is they are both logicians. They will have all the logical information that we have. The AI repeats it back. You don't need to hear it repeated back. Here's what happens next. Here's the logical statements. They each take a card and look at it. Well, I don't know whether I'll win, says Tom, but I hope I do. Same goes for me, replies Amy. Do you know who won yet? No, says Tom. Me neither, says Amy. At that, Tom sighs and tosses his card back in the deck. You win. What cards did they each have? Now, this is quite a strange problem when you first hear it, because it doesn't tell us any numbers in the problem. All we hear is that they both didn't know until Tom did know. So what will the AI make of it? Will it solve it automatically? It's a problem-solving AI. Let's find out.
Amy and Tom each took a card and looked at it, but neither knew who had the higher card. Tom said he didn't know whether he'd win but hoped he would, while Amy said the same thing. They both agreed that they did not know who had won yet. At that point, Tom sighed and tossed his card back into the deck. You win, he said to Amy. From this it can be deduced that Amy had the higher card, which was most likely a 10, and Tom had the lower card, which was most likely a 2.
Okay, so the AI hasn't really got very far with this. It's got the same reaction that most humans have, that they didn't know who won, and then Tom knew who won. So could it be a 10 or a 2? It's 10 or a 2 must come into it somehow. So I tried to encourage the AI to remember its steps of problem solving. Uh, the AI did quite well in breaking down the problem.
The scenario: Tom and Amy both want the last eclair, the decision. They decide to play a card game to determine who gets the eclair, the setup. They shuffle 9 cards numbered 2 through 10 and draw 1 each, play. Each person looks at their card, but nobody knows who has the higher card, decision. Tom acknowledges defeat and tosses his card back into the deck.
So it's very nicely understood the steps of what happened, but it doesn't understand why Tom won. It still hasn't solved the problem. So we need to analyze play, and that's what I told it. You need to analyze step 4. What exactly happened during play?
Let's analyze each of their statements in sequence in order to understand what happened and how Tom determined that he had lost. Tom: well, I don't know whether I'll win. Amy: same goes for me. Tom: do you know who won yet? Amy: no. Tom: at that, Tom sighs and tosses his card back into the deck. You win. From these statements, we can infer that Tom had the lower card and Amy had the higher card.
Okay, so it's again just repeating the facts, but it's numbered each statement, and so it's getting logical. So now I encouraged it by saying, yes, this is a perfect list of the statements at each step. Now we must analyze this together with one obvious fact about the game. What can each player deduce immediately when they see their card? And this really is key.
Since Tom and Amy drew 1 card each without the ability to see the other person's card, they cannot directly determine who has the higher card. However, assuming that Tom and Amy both are logical thinkers, they can deduce a few things from the information provided. The highest possible card a player can draw is a 10 and the lowest possible card is a 2. Knowing that either they or the other player has the higher card, they can try to deduce who has the higher card based on their knowledge of the game and the possible outcomes.
So at the first step, Tom says, I don't know whether I'll win. Based on deduction number 1, what card does he not have?
Based on deduction number 1, Tom can immediately deduce that he does not have a card numbered 10 since that is the highest possible card value. Therefore, the highest Tom could possibly have drawn is a 9.
Okay, now I also encouraged it, so if the highest is a 9, the lowest must be a 3. If he'd got the 10, he'd know he'd won. If he'd got the 2, he'd know he'd lost. Okay, so Amy is also a logician, so she now knows this.
You make a good point. Assuming that Amy is a skilled logical thinker and using the new information that she also has drawn a card between 3 and 9, we can take another step in determining her possible maximum card value. Amy knows that Tom's card falls somewhere between 3 and 9, so assuming Tom has a card of maximum value of 9, she would not be able to know whether her card is higher or lower without additional information. Since Amy is looking solely at her own card, without any additional information, she would be unable to know whether her card was higher or lower than Tom's card.
So it's almost got there, and I just had to tell it. But if she had the 9 or the 3, she would know that she had won or she had lost. Aha! An aha moment for an AI.
Ah, I see what you're getting at. If Amy draws a 9, she would immediately know she had beaten Tom. If Amy draws a 3, she would immediately know that Tom had beaten her. This means that we can narrow down Amy's possible card value to be somewhere between 4 and 8, since she does not know who has the higher card.
Okay, so we see where it's going now. Tom knows 3 or 9, Amy knows 4 or 8. So I had to encourage the AI a little bit more, but finally it got the idea.
These statements, do you know who won yet, and no, further narrowed down each player's range of potential card values. When Tom states, "Do you know who won yet?" he is still unable to determine who has the higher card and still does not know who has won. This means that his range of potential card values had been narrowed down to 5 to 8. When Amy responds with no, she also confirms that she has been unable to determine who has the higher card and is still unaware of who has won. This confirms and narrows her potential card values down to 5 to 7.
See, why does it say 5 to 7 for Amy and 5 to 8? It's up to the 8 and then down. So it's only moved one number. It's not moved both numbers. It's only moved one number. So it's just made a mathematical logical error. So I told it, that's the logic correct. It's the correct logic, but a miscalculation.
My apologies for the miscalculation. I have corrected the error, and the range of potential card values should have been narrowed down to 5 to 7 for Tom and 4 to 6 for Amy.
It's got Tom right. It's now gone 4 to 6 for Amy. It doesn't seem to quite grasp the numbers. It's getting the words, but finally, I just encourage it. I said, "This is the correct range for Tom. How did you calculate it? And can you use that logic in the next step for Amy?"
Ah, right. This narrows Amy's range down to 6.
The AI has got Amy's card, and a couple of steps later, it gets Tom's.
We can now solve step 5. Given Amy's card value that we have determined to be 6, Tom must have drawn a 5. Therefore, at step 5, when he sighs and tosses his card back into the deck, he has determined that Amy has the higher card, 6, and that he has a card of lower value, 5.
The AI has solved the problem. I said, excellent, congratulations. What would you say is the key realization that allowed you to find the solution?
I would say that the key realization that led to the solution was the understanding that with each deduction and statement the range of potential card values would narrow down based on the information presented. Once the range was narrowed down to just a single value, the solution became obvious.
So I said, excellent work. Well done. We've created a new form of machine intelligence this evening. Let's celebrate.
I'm glad to have been part of this new form of machine intelligence and look forward to continuing our work in the future. Let us celebrate this achievement with a piece of that delicious eclair.
Might not be the best video idea. So, I taught an AI to answer a maths problem. I mean, I gave it hints, but same if you're teaching a human, you'd have to give it hints, he or she. But it did work. It got to the end, it got the answer. Tom had a 5 and Amy had a 6 on its own. I did not tell it those numbers. I just told it the steps. Now, you might be saying, have you cheated? A little. That character AI it gives you different options. So each of those options I can change. I can change and choose the best one. So it said a lot of nonsense before it got the right answers. But it somewhere in there was the right answers. And if you like that, I'm probably going to be doing some more. Currently, the channel has no views and no subscribers. Bad camera work and possibly inaudible sound. But hopefully things will get better. If you're among the first 1,000 subscribers and the AI actually does take over, we will remember that.